moment here. Can you see my title screen slide?
Yes, we see it.
All right, great. Should I just go then?
Yes, go ahead.
Great. So this is an announcement of the release of JSoar 4.0.2, which I sent an announcement about yesterday. But it's I'm going to use this opportunity as a more basic introduction to JSoar as well. So JSoar, interesting. Okay, sorry, I clicked in the wrong place. There we go. JSoar is an open source port of CSoar with supporting tools. Most of the core of JSoar is a line-by-line port, by which I mean there are comments in the code that say this came from this function in CSoar, which at least at the time it was ported was on this line of this file. And then you can see, like, it's almost exactly the same with all the arrows changed to dots and, stuff like that. It has been refactored to be object-oriented, and so everything's made into neat classes, but it is the same code. And so we're talking about things like the read, the decision cycle, chunking, not chunking 2.0, I'll get to that, but everything that exists at the time. I actually did a closer inspection this morning, and I think it's more accurate to say that JSoar most closely resembles CSoar 9.4. But it has some of the newer stuff, which I'll get to. The way that I/O works, however, is very different, but this is a good thing for Java applications. Anyway, I can talk about that later. So why would you use JSoar? In our experience, us being Soar technology, it greatly reduces the cost of integrating Soar with Java systems. It's geared towards efficient engineering of applied real-world systems, and so we're very much concerned with how quickly we can integrate Soar with various Java applications. We have non-Java applications as well, and for those we would typically use CSoar. We're much more concerned about the engineering side as opposed to the research side. And sometimes it's actually easier to prototype work. I would actually say it's always easier to prototype work in Java first. And for example, here are some things that were prototyped in JSoar before they were done in CSoar. In reinforcement learning, there was this issue with letting the last rule in a substate fire to put a reward on the reward link before the substate got retracted. That was done in JSoar first. Soar technology actually added the ability to have math in semantic memory queries. You can say, like, find me a chunk where the value of this is less than that. That was done in JSoar first. And CSoar has an output manager, which is not a direct port of the JSoar one, but was inspired by it. So I would say in general, if you didn't already have all your research done in C++, it might have been nicer to start with JSoar, but there's reasons not to do that as well, which I'll get to. Here's a quick comparison between the two. So I've kind of done it on version numbers for a lot of this. So for the commands, we did port the command restructure from CSoar 9.6. And so that JSoar has that now, along with all the same aliases and everything. And for all the major features, reinforcement learning, semantic memory, episodic memory, working memory activation, those are all kind of on the 9.4 version. That was the last time that they were updated. It was actually updated a couple months before 9.4 came out, so 9.4-ish. SVS was never ported to JSoar, and I think that is not going to be a direct port, is what it boils down to. And then there's a bunch of other differences. So the way that I/O works in CSoar is you do it through SML. The way it works in JSoar is there are several different approaches supported depending on your specific needs, but none of them are SML. And then threading in CSoar, every agent in the kernel shares the same single thread, whereas in JSoar you can do that if you want to, but you can also have a thread per agent, and that's how we would typically do these things. Language support is interesting. So they both support Soar and Tickle for rules, and I'm not going to get into why you would use Tickle here. That will be in my next talk. Other than that, they're pretty different. So CSoar uses Swig to wrap the SML APIs. It's got Java, Python, PHP, Tickle, etc. Why don't we just use the Java Swig wrapper? Because it's not a very Java-like Swig wrapper. When you still have to manually delete memory, that's not really what Java people expect. On the JSoar side, it's just Soar, but it's just Java as far as the APIs go. But you can actually have inline in your Soar code, JavaScript, Python, Ruby, Clojure. There might be some other things too. And what does that do for you? And how is that different than the Tickle stuff? It's things like you can define right-hand side functions in JavaScript straight in your Soar code, and then when you source it, it just works. Stuff like that. On the performance side, if you're talking about raw decision cycle time, as far as like, say you're running a Towers of Hanoi agent and it doesn't do any IO and all it does is like run as fast as possible in memory, then CSoar is definitely going to be faster, probably about 5 times faster. And JSoar will use more memory than CSoar, and largely that's because it's Java and the JVM manage memory completely differently, and minimizing memory is not typically the goal. And then, but for more complex situations where there's a lot of IO going on or there's multiple agents going on, some of the features of JSoar as far as threading the agents and these different IO approaches could actually make it faster than CSoar, but this is going to be very specific to particular applications and the nuances of those applications. And so it's very difficult to make a general statement about that stuff. Okay. JSoar has a bunch of different tools and resources I just wanted to make people aware of. There's the JSoar debugger, which is not a port of the CSoar debugger, and I will demo that later. There's Soar Unit, which is it's a unit testing framework for Soar, and it actually works with CSoar as well, although getting it set up can be challenging. For CSoar, for JSoar, it's really easy. There's Legilimens, which is the web-based debugger, and so this is how you would remotely debug a system in JSoar. Basically, it spins up a little web server, and then you can connect to a particular IP address or web address or whatever. Typically, it's going to be localhost, and you'll be able to get to the debugger. And then there's also the JSoar wiki on GitHub, which is apparently very easy to miss. And so there is a wiki, and there's a ton of information there with examples and references to the code and so on. If you are interested in trying out JSoar and just want to know, for example, how do you do IO in JSoar, there's lots of information there. As of 4.0.0, JSoar is now on Maven Central. If you don't know what that is, then this will be less interesting to you, but basically you can use a lot of different dependency managers in Java, whether it be Maven or whether it be Gradle or whatever your favorite one is, and you can pull down the public release of JSoar directly without having to like go to the JSoar web page and download the pre-built jars or anything like that. And that includes the source and Javadoc jars. And so even if you have this like external opaque dependency, you can still like step into it if you're debugging and things like that. Okay. As I mentioned before, one of the new things in 4.0 was the CSoar compatibility with the commands. And so, so that's still there. And now I'm going to basically jump into the demo because it's easier to show these things than to talk about them. So here's the JSoar debugger. Hopefully that's popped up on my screen. You'll notice immediately that it has this yellow background. That is part of the syntax highlighting support. And so sorry, it's very slow with Zoom sharing my screen. And so we've added, one of the goals of the 4.0 release was to make Soar more accessible to people learning Soar, because we always have people doing that at SoarTech. And so one of the things that we did was we added syntax highlighting to the trace. And you can see some simple examples here. You can see when the impasse is occurring. You can see the commands highlighted and these different things here. It's even more apparent if I were to go up to say watch 4 and let's see, run a couple decisions there. And then you can see things like when working memory is coming in and out is highlighted, and when rules are firing and retracting, that's highlighted, and so on. And so this doesn't, if you're an old hat to Soar, this might not be that big of a deal to you, but it definitely helps new people. And so the other thing you'll see here is that I'm getting pop-up help for the commands that I'm typing. And so as I type the run command, it's telling me like, oh, there's these other options and what they do and so on. I can also do, let's see, if I did a, okay, it doesn't want to do this for me right now. Interesting. It's supposed to be, oh, I see, it's on my other screen. Well, apparently there's a bug, but it's supposed to drop up possible auto-completions for this. And so on my other screen, if I type this, it says matches, man, and max elaborations, which I could then select one from that list, but for whatever reason, it's not showing up over here. So you get auto-completion, which I think is also super helpful for new users because it's really command discovery. I don't know how many times I've had people come to my office and ask, you know, how do you do this in Soar? Can Soar do that? And I'm like, well, of course, there's a command for that. I mean, even something as simple as matches, people don't know it exists. And you say, like, it's in the tutorial, but yeah, this tutorial is like a fire hose and, you know, people just can't maintain it all. And so constant support during the actual usage, I think, is super helpful. And so anyway, and then, you know, that help extends to the, if I want to say, I don't know, production. You know, you can obviously get the help directly there as well. So, you can get help for the specific subcommands as well. So if I want to know, like, what does help, you know, on the matches, interesting. Gave me something and then it gave me an error. So there's another bug that I'll fix. Okay, so anyway, that's the kind of stuff you can do. Other things that have been updated recently include high DPI display support. So we updated, so if you're running in Java 11, like I am right now, then it just automatically works. If you're running in Java 8, there are either command line options that you can set, or you can like control scroll to change the zoom level. That's imperfect, but it actually works well enough for the vast majority of cases.
You have about 2 minutes.
All right, so I'm just going to skip back to my presentation here. And I talked about all this stuff. I'm not going to talk about that. Okay, so future of JSoar, it's complicated. Message me later if you want to talk about it. Any questions?
Yes. So Maven asked, how feasible would it be to create a version of the JSoar debugger that could interface to the CSoar kernel instead?
That's a good question. I would say the biggest issue right now is that JSoar does not have support for directly remote interfacing to another to CSoar, in which it would be like a cross-process thing. Well, let's see, could you do it? You could do it. It would not be trivial. So.
Okay. We have about 1 minute left, but Nate would love to hear about the complicated part.
So of the future of JSoar?
Yes.
So basically, JSoar is in maintenance mode right now, and what that means is that we will continue to keep it running because people use it a lot. Like we have many, many projects at SoarTech that are using it. But when it comes to porting new features like, say, chunking 2.0 or the latest updates to episodic memory or whatever it might be. That really, for us, is a demand signal based thing and a funding thing. And so we need demand signal plus funding in order to be able to actually do that. Of course, it is open source, so we accept public contributions if anybody wants to do that.
Okay.